On this slide, we're going to be using the standard solver sheet in the Excel file to demonstrate the use of Excel's built-in solver. And after that demo, we'll exclusively use the premium solver to provide a richer set of analysis and reporting tools, etc., etc. Okay, somewhat confusingly, once you add that solver add-in, as I showed in the previous slide and in Excel using this Excel options add-in, the link to the tool is under Data tab rather than what will be probably more intuitive, the add-ins tab. So rather than the add-ins tab, you're going to go to the Data tab and then all the way to the right to access the built-in Excel solver. Okay, the add-in tab for the premium solver is going to be under add-ins tab right here, either above or below this Excel Miner. Okay, this will be used in the next slide, so hang on with that one for that one. So I'm going to switch back to the presentation, right, and sort of discuss what we're going to do next. Okay, so the current slide shows how to set up the optimization model with a standard solver after it is launched from the Data tab, which we'll do in a second. First, you select the cell D16, okay, as the one containing the objective function, which is the profit function in our case. Then you check the option button to minimize it, which is checked by default. All right. If you then you proceed by selecting cells B11 through C11 as the changing variable cells, that is, our decision variables in the model section. One by one, you add the two constraints. The order does not matter. These are shown right here. To construct the constraint, you have to be clear on what is the left-hand side and what is the right-hand side. The left-hand side, or LHS, as in a constraint equation for the labor, is in cell D12 right here. So that's the left-hand side, and it's an equation, right? The right-hand side is the labor availability, and that one's in cell D4. Okay, that's the actual number. And the same holds for the material constraint. The LHS equation is in cell D13, okay, which needs to be less than or equal to the material availability, which is the constant or just a number in cell D5 in the data section of the optimization model. Okay, then you make sure the box for make unconstrained variables and or negative is checked. This is equivalent to making both x1 and x2 greater than or equal to 0. Finally, make sure the simplex LP method, to be discussed briefly a few slides down the road, is checked right here. It's selected, I guess, from the list. Okay, as the comment states, we use LP, the comment down here. We use the LP method or LP simplex engine to solve linear problems, right? Such as our 2x2 product mix example. Okay. After you hit the solve button, the one at the bottom, the solver results window right here on the right, stating that the optimal solution was found, will pop up almost instantaneously. That will definitely not be the case for large and complex problems where finding the optimal solution may take quite a long time. Since we're not going to be using standard solver that much, we're going to just click OK right here and verify that we got the correct result. So now I'm actually going to switch back and do this in Excel in the standard solver section, right? So I'm going to go under the Data tab, click on the solver. Okay, select the profit cell, total profit cell D16, make sure it's maximized by changing the production of drug 1 and drug 2 in cells X1 and X2. All right, and then add in the constraints. First, I'm going to add the labor constraint, making sure that I know that the left-hand side is this calculation over here, less than the right-hand side is the actual data piece or the number or constant 12. Okay, and it's going to pop up over here, and I'm going to add in the same fashion the total material used, which has to be less than total material available. Okay, if this is not checked, make sure that make unconstrained variables non-negative is checked, and the same thing for the simplex method. All right, now Whether I start, we'll discuss later on on the slide that discuss how the solver actually works. What the, what is the implication of the different starting points. I have this 1, 3, but might as well close this and put this back at 0, 0, right? 0, 0 is again equivalent of that, bottom left corner of the feasible region. And then you'll see when I go back to the solver, the model is still saved. If you want to, reset, if you click the reset all button, then the model is basically essentially deleted and you have to recreate it. You can obviously use the change button to modify a particular aspect of the model, or delete button to delete particular aspect of the model. And there's a couple of options we'll discuss later on, but for now, I'll just hit the solve button. Okay, observe that the solver has found a solution with all constraints and optimality conditions satisfied. Okay, we want to keep it as it shows 1.22.4 with with $9.6 of the optimal solution we are familiar with. Okay, now I'm going to switch back to the presentation and pause. Now we're going to replicate the result with a premium solver, which is available under add-ins tab as indicated before. We're going to follow the instructions on this slide to add the objective function in D16, decision variables in cells B11, C11, as well as the two constraints shown right here, right? I'm going to make sure that just like in this, for a standard solver, we'll check the unconstrained variables, making sure the unconstrained variables are non-negative, and then use LP quadratic solving method, which is equivalent to that simplex method used with the standard solver, right? Then we're going to hit solve to run the premium solver, and we're going to choose to display answer and sensitivity reports, right? So after you're done setting up and running the premium solver, okay, that both of the screenshots will look like this, right? Maximizing profit D16, changing the production mix or decision variables, a decision vector XB11, C11 with the labor, subject to labor and material constraints, non-negative variables, standard LP quadratic, and then once it converges in the solution, 1.22.4, right, with $9.60 as the optimal value of the profit, we're going to choose both answer and sensitivity reports. So to demonstrate that, switch to Excel, click on the premium solver sheet, which looks exactly the same as the standard solver sheet, and then under add-ins tab, click on the premium solver, objective, add cell B6, D16 rather, to maximize by changing variables or variable decision cells B11, C11, and then adding constraints on labor used is less than 12 hours and material used is less than 6 pounds. Okay, make sure that again this box is checked and that LP quadratic option is there, right? Now, in addition to that, before I solve this, I'm going to show you an analytic solver platform, options tab, general tab, operating mode, switch it from guided to auto help, and then when you go back and run it, you're not going to get these sort of annoying guided messages, but it's going to go straight to solving the problem. Okay, and then choose both answer and sensitivity reports, and you're going to get two new sheets. Answer report, which I want to move after the premium solver, and we'll discuss it immediately, and then sensitivity report, which is going to be discussed in some of the subsequent videos. Okay, so the answer report, I'm going to zoom in. Okay, zoom in to the bottom part. That's the actual report, skipping those sort of log messages towards the top. Okay, so described right in these three sections: objective, decision, variable cells, and constraints. And on this slide is the basic info about a solution, right? Where the objective cell, the maximum of this total profit is the optimum value 9.6 with the original of 0. Decision variable cells, the optimum values are at 1.22.4. The original value is 0, 0 for both of these right here and here. Okay, and constraints, all the labor was used, all the materials, all 12 hours, all 6 pounds. So that makes both, right? That's just shown here, but makes them both binding with no slack, right? So binding constraint is when the cell value or left hand side is equal to right hand side. In other words, all of the labor and all of the material was used. And the slack is the difference between the left hand side and right hand side. In this case is 0. There isn't any because everything was used up. There is no leftover labor or material. Okay, so I'm going to switch back here and pause.